Hello, everyone. Welcome to Study Guide Forum. Today we'll be looking at the periodic table, and the area we'll be looking at is the first 20 elements. So, if you're joining us for the first time, we want to encourage you to subscribe to our channel, and then we share and like. Make sure you tell your friends about us. Let the people that the students that really need this thing, let it get to their hands. All right. So today we'll be looking at the periodic table. Now, this periodic table, um, it was formulated by a Russian scientist, which is called the person that is called um, Mendeleev in 1869. Then, when he did the first one, he used a relative atomic mass to, arrange these elements based on their words, their activities. He was able to discover that there's a kind of reoccurrence in each of their properties. But as time goes on, when they discovered the atomic structure, then scientists discovered that actually it's not all about the relative atomic mass, or rather it has something to do with um, atomic mass itself. The atomic mass play a very important role in what we have. So based on that, they found out that if all the elements are arranged, if they are arranged in their increasing atomic number, there is always a reoccurrence of physical and chemical properties of each of these elements. There's a kind of reoccurrence. So that's how they come up with the what? The periodic law, which states that the properties of an element, that is to say, the properties, both physical and chemical properties of an element, is what of the periodic function of the atomic number. Because as the atomic number is increasing, there tends to be a kind of reoccurrence of the properties, reoccur of the what properties of each of these elements. So in that case, here we're going to be looking at some of the features of what periodic table. Periodic table, as we look at it from the table we have here, just a little sketch of this, even though it does not look so wonderful. Just bear with me. We're just using it to help us to understand this very well. Just looking at this very well, we find out that in this sketch we have it has two periodic table has two basic features. One of the features here is the what? The group. And the other one again is the what? The period. Now, how do you identify a group? The vertical column of each of these things is known as the what? The group. And in this group, we have how many? One, two, three, four, five, six, seven, eight. The one we give the number zero is what? The eighth uh, group. And all of them, there's something about them. There's something about these groups. They have some similar properties. The chemical reactivity, the way they react, it seems to be the same. It's either it's going down or it's increasing. Now, what is the cause of this? There are basic cause of this ability to show basic similarities. These similarities they have is as a result of what is observed from each of them. Now, for you to identify a group, for example, when we look at the group one, you find out that for each of their outermost shell, for this group one, they have one electron in their what? Outermost shell. Now, coming down to this other one, the sodium also, lithium is one electron in the S block. um, Sodium is also one electron, potassium is also one electron. That's how you can identify them. Another thing about them is that they have um, their chemical reaction, they undergo similar chemical reactions. Now, we will come over to this other end, we will come to the group 2, where we have calcium, magnesium, and beryllium, then we notice that they have two electrons in the s block. Now, the same thing goes on and on. Here we have three. Group 3, you notice this alone. You notice that we have what? 2, 3. For group 4, we have 2, 4. For group 5, we have 2, 3, giving us 5. Here we have 4, 2, giving us 6. And the group 7, we have 5 plus 2, we have 7. And the last group here, where we have 8, that means we have 8 here, and this other one is 2. Now, there's something about it. The S block is complete whenever it has 2 electrons, while the other blocks, that is S and P block is complete when it has what? 6 electrons. Now, you find out that all this area, what they have in common here is that all of them have a completely filled um, electrons in their atomos shell. The atomos shell is completely filled up. Now, that is why we call them noble gases, and they are also known as, they are inactive because of inability of undergoing any chemical reactions. Now, how do, like I've already stated, you now you'll be able, I believe that by now you'll be able to identify these groups, how you can see them. Like I told you, just note very well, vertical columns, each of them is known as what? Groups. Then, how do we also identify the another feature of the periodic table? Another feature of this periodic table is also the the periods. The period. When we go horizontally, when we move horizontally in each of these column, you find out for the first 20 elements, you find out we have about how many? One, two, three, four. We have what? Three periods horizontally. One, two, three, and four. That is what we have. And how do we know that this is, how do we know elements in the same period? We note them by the number of shells they have, the number of shells they have for each period. For each period, they have the same number of shells. Now, in this case, I just listed out this to help us understand the groups, because if you look at this, find out the all we have here is just the atom of the last shells. The last shells is what we have here. In each of the last shells for the group, like I have already explained before, each of the last shells of this, they have the same number of what? Electron. Now, how do we know the period now? The period is known by the number of the highest occupied shell. The highest occupied shell. Now, when we look at this thing, you look at in this case, you have the last shell they have here. The last shell they have here is 2. Is 2 that they have here. That means this belongs to what? 2. The quantum number here is 2. That means it belongs to what? Period 2. Here we have 1. That means this one belongs to what? Period 1. In this other one, we have what? 3. Meaning that sodium belongs to what? Period 3. The same thing, all of them, you go from here, you find out that all of them are what? 3, 3, 3, 3, 3, all the way. That means all of them belong to the same period. When you arrange them in based on their electronic configuration, when you write out their electronic configuration, you find out all of them will rhyme with this thing, with this structure or configuration. You find out that all of them run in that form. Now, how do you look at this other one too? For potassium and calcium, you find out that they are all what? 4. That means the number of shells they have here, the number of shells they have here is up to what? 4. All right. There are some other things we should also note about this um, all these periods when we talk about the periodic table. In this periodic table, now in our next class, we'll be going into details in some of these features. For example, moving from left to right, there is increase in electronegativity. These are some of the things we are going to be looking at in our next class. And down the group for the metallic element, there is always going down the group, the reactivity tends to what? Increase. There is increase in reactivity, while in the non-metal zone, um, down the group there is decrease in reactivity. Now in the next class we are going to be looking into this into details, and in that class we'll be able to know how the uh, force of attraction, the nuclear charge, the attractive force of the nucleus helped to make this impossible, and the screening effect of the electrons, how it makes all these things possible. Thank you for coming this far, and remain blessed, and make sure you don't miss our next video that's coming up. Thank you so much.